All right. Hi, everyone. I know people kind of filter in as we go, but thought I'd start it at the hour to give Alyse enough time to give her whole presentation. So today, Alyse Staley, who's a biostatistician with the BBSR, is going to give a talk about improving efficiency with R. So, Alyse, I'll turn it over to you, and looking forward to hearing this talk.
Great, thanks, Andrew. So today I will present about using R Markdown, and RStudio to make aspects of the data analysis process more efficient through automation. The first steps of most data analysis projects are very similar, so it saves time to automate as much of this process as possible. Today, I will first focus on a specific type of automation, which is using custom templates to save commonly used code in one place. First, I'll go through a data quality checking template. Then I'll show you how to create a template to format your reports, both for HTML and Word. And finally, I'll go through how to save these templates directly into RStudio for easy access. I will then move on to show how these templates can be incorporated into a general project setup. This includes source control, automatically creating subdirectories of each project folder, using the templates in practice, and using batch files to quickly back up your work. I'm first going to start with custom templates. The first step of every data analysis project should be data quality checking. And a lot of this process is repetitive and can be automated with functions. Having a template is also useful because it helps to remind us as statisticians to check all important features of the data. Additionally, I want to point out that this template is a starting point. Each data project is unique, and you'll often have to add some code to check these specific differences for that given data set. To start, I will go through the functions that I incorporate into this data quality checking template. Here is a R Markdown document, and to start, here is a helper function that helps to change the data upfront into any format you are interested in, whether that be factor, character, or numeric. Next, it's always important to check the univariate distributional properties of each variable in your data set. So I've created a function here that takes the entire data frame and then separates it by the type of variable, whether that be numeric or character or factor. For numeric variables, this function returns some summary statistics, as well as both a histogram and a QQ plot of each variable. For character and factor variables, it returns a frequency table. Additionally, if your dataset has missing data, it's important to explore those patterns. One way to do this is through this univariate missing function, and all this does is it subsets the data to incomplete cases. This way, you can see if the distributions look similar in the incomplete cases to the overall observations. Later in the talk, when I show these functions in action, I'll also show you how to use the mice package that does a nice job of also checking for missing data. Next, it's important to examine the bivariate relationships between each variable. This first function is a broad overview of the bivariate pairs of each set of variables. It takes advantage of the ggalley package's ggpairs function and also gives you a message to let you know if any of your character or factor variables had too many levels to be included in the plot. After getting the overview, this next bivariate check function can zoom in on important bivariate relationships. This could be something that's particularly important to your data set. Maybe it's something you identified as unusual from the overall bivariate pair section, or perhaps it was just something with so many different levels that it was hard to see. This function first, again, separates the data into character or factor or numeric. And when both x and y are numeric, it returns a scatter plot. When one of the two variables is numeric and the other is a character or factor, it returns a box plot. And when both variables are characters or factors, it returns a bar plot. All of these functions are then saved into a workspace, which brings us into the data checking template itself. Here's another R Markdown document, and you can see one of the first lines of code is that it loads the functions we already created. Now, a more elegant way to do this would be to create your own R package, but today I'm focusing on the simplest way to go about this for your own personal needs, and so loading a workspace does the job. Additionally, this already loads any library I might need for the rest of data quality checking, has some skeleton code to import the data, and also has any other operators that I may need. For example, I personally like to code in the tidyverse, and I find the negating exclamation marks to be more cumbersome than creating my own not in operator. Now this template goes through each primary step of the data quality checking process. It uses some base R functions to give a broad overview of the data, and also checks for duplicate observations or rows. Then there's skeleton code to apply each of the functions that we went through previously. Here you can change the type of data, check the univariate distribution, check the missing data. This is the MD pattern function from the mice package that I alluded to earlier, and it does a really nice job of looking at the patterns of missingness in the data, which will make more sense when we go through a real example later. Finally, there is also code ready to check the bivariate relationships in the data. Next, I would like to show you how to create templates for reports. It's important to have professionally formatted reports to turn into investigators, and using R Markdown, HTML is pretty user-friendly. However, in my experience, some investigators prefer Word because they might want to use track changes or comment the writing that is not very easy to do in HTML. However, Word is more difficult to format, and so I'll spend more time going through how to do that. Having these templates is also important simply because it's efficient. Formatting takes a lot of time, and by creating a template, we only have to format all of our documents once. Here's another R Markdown document that can be used as a template. In this header, there is room for a title. It already has the analyst name, myself, written in. It has room to enter in the investigator who I would be collaborating with on a given project, and it has room for the date. Starting with HTML, this has everything we need to make a nicely formatted report. It's automatically formatted, the sections are numbered, and there's even a table of contents. Next, here is some code that automatically creates subdirectories in your project folder. This takes advantage advantage of the CETA tools package, which our colleagues over at CETA have created. And this function automatically creates subdirectories and README files within the project. This can include the background, where you might put relevant emails or literature, code for any scripts, data raw for any data directly received from the investigator, data processed for any formatted or cleaned data, and reports for any deliverables. Since this was designed by CETA, it only has this one folder structure, but if you have different folder names that you're interested in, you should be able to edit the source code pretty easily if you go into CRAN. Then there is some skeleton code, just as we talked about in the last item, to load the libraries and import the data. Next, I want to direct your attention to this Word output section. You can see that there is a reference document here. This is a Word document that has already been custom formatting to have the format that we want every report to have. Now, when we knit this to Word, it will follow the formatting in this reference document, which is now what I will go through and show you how to do. The first step is to open up an R Markdown document and include any element that you want to format. In this case, I've included a title, 3 different levels of headers, and some free text. You could also add something like a table here. What you have written, however, does not matter. This reference document is only extracting the formatting, not the content. So I'll go ahead and knit this arbitrary document to Word. This is now the format that is automatically used for an R Markdown document, which isn't my personal favorite. Let's say I want the title to be formatted differently. The first step is to highlight it and then navigate to the Styles tab. This is right under Home in Word. Then I will create a style and give it a name. Then click Modify. And here are the basic formatting that we can alter. For example, I'm fine with the font, but I might want it to be smaller. And perhaps I would like it to be black and formatted on the left instead of the center. Here's the preview, and that looks good to me, so I press OK. Then I'll go ahead and format the main header, again navigating to the Styles tab, create a style, and give it a name, modify it, and can again go through any changes that I might want. Gonna bring down the sample size, or the font size, change it to black font, and let's say I want some space between the header and the paragraph. And press OK. Let's say, however, I would also like this section to be numbered. That wasn't an option in the Styles tab, so I can edit it in the body of the document. Highlight it, and I can go here and check my numbering. However, it's very important that the style itself is updated to reflect these changes. So I again highlight this, navigate to Styles, right-click on the formatting, and click Update Header to match selection. Now, if you go over to Styles, you can see this style includes the numbering, and so we're all set to go. For time's sake, I'll skip ahead to the body of the text, and One more time, create a style, give it a name, modify it, and I can go ahead and change the font size. Let's say I also want this double spaced. And it would be nice to have each paragraph automatically start with an indentation. If you right-click on the text, there is a paragraph option in Word under Indents and Spacing Special. And do first line, okay. And that's exactly how I want it. Just need to remember to update the style as well. Right-click, update to match selection. And now I would save this reference document in a convenient spot on my computer. I've already done that ahead of time though, so we won't save this time. Now that we have gone through how to create the templates itself, it's also useful to save the templates directly in RStudio. This makes them, firstly, easy to access, and also avoids accidentally overwriting your code in your template. First step is to open up an R Markdown document, or any R script would also do. And we are going to create a new project. So File, New Project, New Directory, and we will select our package. We then need to give the package a name and make sure it is in the correct directory. It is, so press Create Project. This message indicates that the project was created successfully, and it's actually at this time that I open up the R Markdown document. First, I will load the Use This library to create a template. If you haven't installed it, you will need to do so. Then the Use This library has a convenient function called Use Our Markdown Template. At this point, I simply need to give the template a name. I will call it Report. I'll go ahead and run this. And we have this message here saying that it was successfully created. Next, I will navigate to the directory we just created, so testing package. In here is an inst folder, and I keep clicking through into templates. If we had created multiple templates, there would be multiple folders here. And I'll go through report, which is the one we just created, navigate to the skeleton file, and finally, there is a skeleton document. The skeleton document is completely blank, and that's because we can put in whatever template we want here. I'll navigate back to the templates we just talked about. Here's the report template, and I'll copy the entire thing over and paste it in the skeleton code. The next step is to save, and then navigate over to the right where you will see the Build tab, and select Install and Restart. Okay, we should be all set now. And if we go out of this and we want to open a template, we can go to our Markdown and select From Template. Here are templates from other packages, And here is the testing package that we just created. In there is a template called report. Click on this, press OK, and now the template is ready to be edited. Let's say at this point, we actually decide that we want to edit the template. Well, the first thing is to go into the package and open up the project. Otherwise, this won't work. Okay. We have the project open, and now we need to navigate back to that skeleton code. Let's say I don't actually want the folder structure in this template, and maybe I want it in a different one. Go ahead, delete this, save, install, and restart. Now, if I go back to open a template, so our markdown from template, testing package report, it no longer has the code that we deleted. Right, now that we have gone through creating templates, I will now transition to going through initiating a project. As I briefly mentioned earlier, this will include using source control, automatically creating the folder structure through the function I introduced before, using templates in action, and using batch files to back up our work. The first part of this demo will include using source control. For those of you who are unfamiliar with it, source control is a way to iteratively keep track of your changes within a given document and within a given project directory. I personally use GitKraken, but there are certainly many other options available. For those of you who aren't familiar, it will make more sense once I go through the demo, but I won't go through it in great detail. So if you have any questions about it, please feel free to reach out to me later. Source control is important, firstly, because it's efficient. It helps you organize your work. Since all of the changes are tracked in source control, you don't have folders that look like this, where you have all of your different reports. Source control also helps to avoid broken code. Sometimes when you're coding something, it will suddenly stop working, and it can take a lot of time to figure out which line of code is causing the problem. But if you use source control and you track your changes consistently, you can revert back to a previous version of your document and not have to spend the time trying to fix the problem. Additionally, source control is important for reproducibility. It keeps a detailed document history, and when multiple people are working on the same project, you can keep track of who made which changes. The next part of the demo will include creating a folder structure using the function I introduced briefly before. This is efficient because it's automated. It takes a lot less time to click a function than it does to create each individual subdirectory with a README file in it. Having an organized folder structure is also important in general because it's easy to pick up where you left off when you have to revisit a project in the future, or if a colleague needs to access your work. The demo will also include using the templates we talked about in the first part of the talk, which is efficient due to automation and standardization. And next, I will show you how to write a simple batch file to back up your work. Backing up work is always important because you avoid losing your work. And I personally like to work out of two folders. One folder is where just iTouch, and I may have very rough drafts of documents or notes that I don't need to share with my colleagues. But then in another folder, I have a folder to collaborate out of. And I need all the same information in both folders. And so what I used to do was copy and paste things over at the end of the day. But this took a lot of time, especially when the files were large, and it ran the risk of forgetting which files I had and had not copied over. With a batch file, a simple click of a button can do this automatically, and it can be done when you have stepped away from your computer at the end of the workday. With that, I will transition right into the demo itself. First, I've started by opening up GitKraken for source control. Here, I will start a local repo, since in this case, we're not pushing it to the internet. And I will give the repository a name. I also need to make sure that it's in the correct subdirectory, which it's not. So I fix that and press select folder. It looks set to go, so I can create the repository. Okay. And you can see that it has now created that folder, testing project. The next step will be to open up the templates that we previously created. Okay, our markdown from template. Here's the package we just created, and these are ones that I created ahead of time in the exact same fashion. So first, I'll open the data quality checking template, and I'll also open the report template. Okay. In the report template is this function needed to create the subdirectories. All I need to do is set the working directory. Down at the bottom, you can see that the directory was changed. Run this. Now that that's been done, I'll take this out of the report. And if we go back to the project, now there is a subdirectory of each folder, and in each subdirectory is a README file where you can outline what each file is for. I will then go back to the source control and record that. Right now, I'm adding a message. I have to stage all of these changes and commit them. Okay. Now I'll go ahead and save these templates. This is the data quality checking one. And here's the report. It is also good practice to update the README file. I name my files in the order I want them to be run. So here's a brief description, text, univariate, and bivariate relationships. And number 2, report summarizing data quality. Save this. And once again, can go to my source control and say, saved templates, updated READMEs, and commit. Next, I will go through creating a batch file. I use Windows. This is a bit different in Mac, but you can't see it on the share I'm sharing, but I'm just typing in Notepad into the search bar right now. And now it's come up. And I will copy over the robocopy command. And as you can see, this is pretty simple. It's only one line of code. The first part of robocopy is to click the current path. So that's the one that you want copied from. Go ahead and do this. And then I would go ahead and add the new file path. If you want to copy this folder to multiple other locations, you could simply copy this entire line and just paste it below. And now when you run this document, it would copy into both file paths that you specify. Then we can go ahead and save this. We're under the correct directory, which is the testing project. And I'll give it a name, batch backup testing. And it's also important, you have to save it as a .bat extension. Change this to all files, .bat, save. And now there is a batch file here. At the end of the day, I could double click this, and the entire folder would be backed up. At this point, I'll now navigate over to a sample project. This again was set up exactly how we just did it. The only difference is in this data raw file, there is some data that has already been loaded. I'll navigate to code and go to data quality checking. You can see I haven't changed much. This is mostly the template that we already created. What I have done is I've set the working directory and indicated which file we want to read in. These data were simulated by Professor Dr. Gary Grunwald for his consulting class, and it was simulated specifically to be very messy. And so it's a good way to test how well your quality checking functions are working. So as a first step, I'll load in that data. First, we can get an initial sense of the data. And at first, I notice that all of the variables are integer. And we'll want to go ahead and change that in the future. Additionally, we get a nice overview of each variable, get its range and some other summary statistics, as well as how many missing variables there are per variable. Additionally, by checking for duplicates, we can see that there are in fact duplicated lines in this data set, but that's because there isn't a patient ID. So I'm not too concerned that in the same hospital in this test data set, there might be more than one patient with the same combination of other variables. Then there is a function to change the data to the correct format. You can see here that I have specified which variables I want to be factor, numeric, and character. And this warning message is just saying I used an outdated version of the tidyverse to create this function, so I'll have to go back one of these days and update the code. Then we can see that it has been changed to all of the formats we specified. Next, I'll move on to univariate data checking. This takes a second to run, and it returns the summary for each variable. For this made up 6-month variable, I can go through this and already notice that there's something a little strange. it appears that there's about the same frequency of each value. However, there's about twice as number of observations for 37 and no observations for 38. For the procedure code, you can see that there are only 2 observations from procedure code 2. So that would inform us as statisticians that that would not be a category we could treat as its own in the analysis. Likewise, that can be said with this ASA variable. And then moving on to continuous variables, here are the different hospital codes. They're about uniformly distributed, which is probably what we would expect, that there's about the same number of observations per hospital. Then we can move on to weight. Clearly there's something a little odd going on here because it's bimodal and is not what I would expect for weight. Weight I would expect to be somewhat normally distributed with perhaps a right tail. And so this would warrant further investigation. Maybe there is a small subset of kids in this data set, or perhaps there's something wrong with the units. This is also clear from the QQ plot. Height looks pretty good, but this is informative because it shows us that height appears to be rounded to the nearest inch. And then we get to BMI. At first, this distribution looks pretty good to me, but under closer examination, you can see that the minimum BMI is 3, which is implausible. This is where we might need to add some extra code to further delve into the data quality checking. We want to see, are these low BMIs coming from a certain hospital, for example? And again, the QQ plot shows that some things might be off. Then we can transition into missing data. This is taking advantage of the mice package. Here, each variable is listed at the top, and on the bottom row are the number of missing variables overall for that variable. So for example, for weight, there are 104 missing observations, which are indicated in pink, and all of the available observations are in blue. Across the rows are the number of observations that fall into each pattern. So the majority of observations have no missing data. This is informative because you can see that anytime weight is missing, BMI is too, which might suggest that they were either collected together or perhaps BMI was calculated from weight within the data set. Then I apply my missing data function, which, if you recall, subsets the data to incomplete cases. And to jump to the chase, if I go to hospital code, you can see that over 70% of the incomplete cases come from hospital code 30. So that's again something that we would have to explore further or reach out to the investigator to figure out what might be going on. We can then move on to the bivariate relationships, and this is printed here that no factor or character variables have more than 15 levels, so everything will be included in this plot. Now we have a nice broad overview of each bivariate relationship. In most cases, this is all we need. This is pretty informative. But in some instances, this doesn't do a nice job because it's too small to see. And this also highlights some distributions that clearly have issues, such as the weight and BMI relationship that doesn't look quite right. So now that we have a broad overview, we can look at more detailed bivariate plots. That is certainly easier to see. And if we navigate over to the weight and BMI, there is clearly two distributions going on. And this suggests to me that there might be an issue with units in the weight variable. Now that we have finished checking the data, here is a sample report that was created with the template. As you can see, it's again referencing that Word document. So if we knit this to Word, it is in the format that we specified in the reference document. And I would say this formatting is pretty close to ready to be able to be sent right to an investigator. All right, so in summary, semi-automation of repetitive tasks increases efficiency and allows us as statisticians to spend more time on the analysis instead of spending time on the really repetitive tasks. Today, I first focused on creating custom templates and saving them in our studio, and then more briefly went through source control, automating folder structures, and using batch backup. This is how I like to organize my work, but everyone has their own preferences. So I hope that today has given some ideas that you can possibly incorporate into your own workflow. Here are some references to some of the resources I use to create this presentation. I'm also more than happy to share my slides and code with anyone who's interested. Additionally, this talk was put on by the Biostatistics and Bioinformatics Shared Resource, and our Biostatistics course can help you with any kind of statistical analysis, study design, manuscript assistance. Whatever your needs are, we can probably help, so please feel free to reach out to us. With that, I conclude my talk, and I will open it up to see whether anyone has any questions or suggestions. Thank you.
Well, it looks like we don't have any questions, which that's a hallmark of a good talk. Then, Alyse, so thank you everybody for joining again, and we look
Andrew,
forward to seeing
there are a
you
couple
next time.
things in chat.
Oh, I see that now. Yeah.
Yeah, I'm looking at those now.
Okay.
So it looks like someone commented about cookie cutter or workflow R. Would you mind, I'm not familiar with that. Would you mind saying a bit more?
Oh yeah, so those are, hi, this is Vlad from the library. Those are packages to set up project outlines, and customize different types of project outlines and project templates. So I was wondering, I mean, yeah, I don't mean anything by it. I mean, if I was wondering if the CEDA folk that made the CEDA tools package looked at it before making the CEDA tools package. If not, then that would explain it.
Yeah, I'm not sure, but that certainly looks like a good thing to look into. So thanks for that.
Yeah, there are some groups on campus that they use Workflower internally for all kinds of things. I'm trying to see, maybe I can get you the right link. And then cookie cutter. Workflower is, if I remember correctly, based off of cookie cutter.
Okay.
Let me see if I can get a. So Workflower, it's R people tend to use Workflower, Python people tend to use cookie cutter, but of course, none of this is mutually exclusive.
Okay, thank you. It looks like the other comments are all on sharing code and slides. So I've put my email in the chat. If you're interested, if you don't mind, please reaching out to me and I'll send those your way.
I have a question. Have you considered using LaTeX? Um, Basically working with R to create something, and you can then convert that into a, say, either a Word document or a PDF, depending on what the output should be.
Thomas, I think it was hard to hear you. That question.
Can you hear me now? Does it work now?
I can hear you. It's just very quiet.
Okay, okay, is this better?
Yes.
I can
Okay.
hear you now.
All right. Sorry about that. It was the audio settings of the damn thing. So have you considered using LaTeX that can work with R, basically knitr or something, and basically to create a document, and then you can either convert that with Pandoc into Word, or you could use that same thing and make a PDF of it, you know, which is basically just as easy as HTML, if not easier, maybe to share.
Yes, thank you. I've certainly run into some nice LaTeX templates that are available online, but I haven't created any specific ones for myself. So I agree, that's a nice way to format things. So that'd be good to look into more.
Yeah, because you can basically, you don't have to, you know, change your styles manually every time. You just make one nice template the way you want it and then just use that.
Great, that'll be good to look into.
Well, I think if there's no other questions, at least like I said, if you want to share your contact info so people can reach out to get your presentation. Otherwise, they can always email our group and we can connect with people that way. But thank you again for attending, and look forward to seeing you next month.
Thank you. Bye.